Is that what you're saying?
Yes.
Right. Now, let's be sure. Could it be a question like find the inverse sine of -1/2? Is that the kind of look to the question you're talking about?
Yeah. But then it's like you have to choose either between like quadrant 1 or 4.
Okay. This is that question because you have to choose between 1 and 4. So in this case, here are the 4 quadrants. And each quadrant, certain trig functions are positive or negative. In the first quadrant, all of them are positive. What about in the second quadrant? Who's positive?
Sine, and then cosine is negative.
Right, and the other two are negative. But in the third quadrant, who is positive?
Tangent.
And in the last one, it's cosine. So whenever you hear me saying all sine, tan, cos, that's what I'm trying to repeat. Now, what this allows us to do is that if you know where something's positive, don't you by implication know that if it ain't positive, it's negative there. So random. Third quadrant, the tangent is positive. Doesn't that also mean the sine and cosine are negative?
Yes.
Right? If the tangent is positive, doesn't that make the cotangent positive? If you take a number and you turn it upside down, it's still positive, right? Different number, but still positive. On the other hand, won't the secant and the cosecant be negative just like the sine and cosine are negative?
Wait, what?
The sine is negative in the third quadrant.
Yeah.
Won't the cosecant be negative in the third quadrant?
Yeah.
That's what I'm saying.
Okay.
Okay. So, phase 1, or step 1. Where is a sine function negative? Which quadrants? Because there are 2, but we only pick one of them.
The fourth and the third one.
So we're looking for it, and we're looking at these 2, right?
Yeah.
Now, the inverse sine function only picks answers, right? This fella here only picks answers from the first and fourth quadrant. And that's just something you memorize. And if you're not good at memorizing it, you write it down on a piece of paper so that it's there when the test comes round, right? So you just have a little list of what the inverse sine function uses. And when you are looking for the inverse sine, it only uses angles in the first and fourth quadrant. Now, can you see then that the answer I pick is the answer in the fourth quadrant?
Yeah.
Now, if you can imagine on top of this, I draw a unit circle. I'm looking for an angle in the unit circle, right? In the fourth quadrant, let's say it's where that dot is. And I'm looking for that angle with an x coordinate of -1/2, right? I don't care what the y coordinate is because it's an inverse sine I'm looking for, right? So what angle in your unit circle, in your unit circle does that? Right, fine.
Is it -330? I mean, 330, like 330 degrees?
Okay, if you're going to do it in degrees, that's correct. But I think a lot of the well, it might be degrees, but let's just say it's radians. So instead of 330, what are you going to?
I'm not good at that.
11 pi over 6.
Thank you. Now, you're thinking to yourself, great, I got the only answer, right? I've got the one in the fourth quadrant, it's 11/6. How hard can this be? This is how hard it can be. The correct answer is -1/6.
That's the part there. I'm like, what the heck are you talking about?
When you are doing angles that are inverse sine questions or inverse cosine, for inverse sines especially, first quadrant, positive angles. Fourth quadrant, negative answers. And that's also part of what you do. So when you're trying to find the inverse sine of -1/2, you know to look in the fourth quadrant because it's negative. and you notice that whatever your answer is, that says negative VE, short for negative, right? That's a negative angle. So your answer will be negative a quarter pi, negative a half pi, negative a sixth pi, right? Things like that.
Bye.
Well,
Okay?
so like, doesn't that rule not apply to when you're doing like negative cosine? Like,
Correct. Let's look at inverse cosines now. Now, each one of the three trig functions have their own specific rules. So I wish it was just one rule and you could remember it all. For the inverse cosine function, it only gets angles from the first and second quadrant. You notice that that's different from the inverse sine.
yes.
Now, if I draw my little all sine tan cos guy again, and I put the labels first, second, third, and fourth, right?
So why can inverse cosine only be in quadrant 1 and 2?
It's defined that way. It needs to be a function. And since for a function, every number must have one answer, they had two possible places it could be, so they said, nope, you're going to get it from 1 and 2. 1 will get you the positive answers, 2 will get you the negative answers. So in this case here, which quadrant is a cosine negative, first or second?
The second one.
Agreed? So I know I'm going to get the angle in the second quadrant. Imagine my unit circle. And let's suppose that the guy I'm wanting is this guy here. When you're talking about the fella that you're looking for here, you're looking for what, negative a half, comma, root 3 upon 2, I believe, right? Right. Has anybody got the unit circle? I was looking for mine, but I think I've accidentally thrown it away.
2 pi over 3.
Oops, thank you. So our final answer is 2/3 pi. Here is the good news. You don't need to worry about changing that. Whatever it is, right? It's the correct answer. Because in the first and the second quadrant, all answers are positive. So the cosine's a little bit more generous. The sine one, you have to say, oh, that guy, but you have to call it negative a sixth, right? That's because it's a sine. And the inverse tan is the same problem, because the inverse tan also uses the first and fourth quadrant.
Then how come in some like problems like oh shoot, like if you do the tangent or like whatever, an inverse of whatever, you can have like two decisions when you make it. Does that make sense? When you're
Right. That is not a function of the inverse function. That's not a function of inverse sine. That's a function of find the missing angle in a triangle question, right? That's a different kind of question.
It's a different
We're talking about a question, what is the only value for this inverse sine?
Yeah.
And this is what you have to do. If you have a question where you're trying to find a missing angle, don't you sometimes find inverse sines and inverse cosines and whatever it is to find missing angles, right?
Yeah.
But in those questions, those are different kinds of questions, because in those questions, there may be two answers, in which case you write down both of them. So they're two distinct types of questions. Question one just says, they might not phrase it this way, but this is the way they probably could phrase it. Find the only angle for the inverse sine of negative a half. The second question is, here's a triangle with some information on it. Find this angle theta, right? An angle theta might have two possible values. Now, when you get theta, don't you have to do things like, well, it'll never be negative for starters, but you have to find things like, you know, the inverse sine of 3/4, right? Or whatever it happens to be. Well, in those questions there, they're not the same as this one. This question here is very specific. What is the single only value for an inverse sine, inverse cosine, inverse tan, right? So as long as you realize when it's this, there's only one answer. But when you're looking at triangles and things, you may sometimes have two answers. They're not really the same question, so you have to treat them differently.
But they all involve inverses.
Yes,
Okay.
they both involve inverses. This one wants to know the one answer that you can get for just an inverse. This one wants to know all the angles, the two angles that you can get. Now, you might use an inverse sign to help you get those two angles, but that's not the goal. The goal is to find two angles. That's a different thing. Don't do that. I actually did something here that I didn't mean to do. I hope I didn't stop someone from coming in. Right, I need a new person with a new topic, or I'll just pick my own. Anybody got a question that they would like me to do?
Sure, I'll go ahead.
Go for it.
So this is about amplitude, period, phase, and horizontal shift.
Okay, good question. How do you get them all and all that good stuff, right?
Yep. I
Okay,
have
so
an equation for you if you want that.
go for it. That's even better.
Y equals 5 sine in parentheses 2t minus pi over 3.
Right. Just in case I haven't done this, so you're looking at a big white piece of paper right now, because I'm never sure what you're saying. Great.
Yes.
So, there is a thing called amplitude. We'll calculate that. There's a thing called period. I'll calculate that. And there's a thing called phase shift. Is that all they want? There's
Horizontal
another
shift.
thing called frequency.
Horizontal shift is the pi third. That was like the weirdest question I've had.
Horizontal shift.
Yeah. It's like
Do they say phase shift as well? Or do they say horizontal?
It says phase and horizontal shift.
horizontal, like the horizontal one's the pi third and the phase shift is like the actual phase shift. I have no idea why they like separated those two.
I have no idea either, because they
Yeah,
end up being the
that's
same thing.
It was in the quiz.
Yeah, they end up being the same thing, at least as far as I can tell. Right, let's look at each piece of the puzzle. The amplitude you get from here. So the amplitude is simply 5. If you want to get the period, it's 2 pi, well, for a sine function at least, it's 2 pi. For a cosine, it's 2 pi. For a secant, it's 2 pi. For a cosecant, it's 2 pi. But for a tangent, it won't be 2 pi in the top. When it's a tangent or a cotangent, what do you use on the top instead of 2 pi?
Pi.
Pi. Right, and it's like 101 other things. You might want to start writing down, if you've a horrible memory like me, things like that, you know, like which quadrant is the inverse sign positive, right? Which quadrant is the inverse sign negative, right? Little niggly things like that that are just rules, right? Things that you need to know. So 2 pi divided by this number here, which I believe in the textbook is probably called omega. It looks like a W. So it's 2 pi over 2. So in this case, you get pi. So the period of this function is pi. So far, so good?
Yes.
Right, now, phase shift. There are two ways to tackle phase shift. They both get you the same answer. They're just different ways of looking at it. The first one is kind of mathematical, in the sense that you do a little bit of algebra. Whatever this number is, pull it out as a common factor. Now, 2t take away pi upon 3 is the same thing as 2 in brackets t take away pi upon 3. If you multiply 2 times t, you get 2t. And if you multiply 2 times this guy, don't you get negative a third pi, right? 2 times a sixth. So do you see that this is the same thing as that? They're just written differently, but they're equivalent. Agreed? Now, if you write it this way, this guy here, call it PS for short, is the phase shift. And the last little thing about phase shift is, if you move it to the right, isn't it pi upon 6? So won't negative 2 be to the right 2, right? And negative pi upon 6 is to the right pi upon 6. So phase shift is positive when that guy is negative. Now I said that there's two ways to do this. The other one is a formula. You take this guy and you divide it by this guy. Do you notice that they're both pi upon 6? So you take this fella here and you divide it by the coefficient of t. So pi upon 3 divided by 2 gets you pi upon 6, and that's the phase shift. And I'm not quite sure why that's there.
It's pi over 3.
Is it pi over 3?
Yeah, that's what the test was. That was on one of the quiz. I know what Olivia's talking about, and that like pissed me off so much.
Yeah, that the horizontal shift of the function really should be pi upon 6. They're just using their definition. I know where it's coming from. They're saying pi upon 3, right?
Yeah.
Yeah, but
I got
you could
mad
argue.
too because
Yeah.
I don't care anymore. I'm just gonna put this random. And it's like,
They
okay.
said that the reason why it's pi over 3 is because you shouldn't mess with the whole equation yet. It should always get the
so you're thinking of
horizontal
this first
shift.
before you do that. Don't like it.
Yeah, me neither.
They said that you should always
Right.
get the horizontal shift before you fix
Yeah.
the equation.
I don't agree with that. I understand they say that, but I don't agree with that. Well, hopefully there are no too many horizontal shifts. I still, the way my mind works, the way I see it is that. Now, you very often get a little picture at the end and they give you like 4 pictures, right? And which one is the right one? So let's see if I can do some of this. It's going to have a range of -5 to 5 because that's what the amplitude is telling me. The period is pi. So if you imagine going there, 1, 2, 3, 4, that would be pi, and that would be a half pi. I'm just breaking into little equal pieces. And what that would do is it would start off here, then it would climb up there, it would get to there, it would go down there, and it would get to there. Now, this is not the final answer. This is leading to the final answer. This here is what 5, the sine of 2t would look like. And this is why I disagree with their horizontal shift. Phase shift we all agree on. Nobody's going to argue about this one. In this case, phase shift is you move the entire curve to the right, pi upon 6, right? The phase shift. That's why I would call the horizontal shift the same thing. I would just consider them the same thing, right? Just different names for it. So if you take this guy and you move, I'm not saying accurate here, but can you imagine that everything just kind of shifted to the right by roughly what pi upon 6 would look like? You're looking for the picture that goes up to 5 and down to -5 and looks something like that dotted shape that I've got. So I would hope that one of the 4 pictures is clearer than that. Now, what they might do is, see that line there, they might just keep it going a little bit further, you know, so that it doesn't just sort of pop into existence, because the curve goes on. I mean, technically speaking, doesn't this curve go on forever as well? So you got that to contend with. Okay, have we got another question? Okay, let me throw in one. Suppose you're being asked to find the exact value of the cosine of the inverse sine of 3/4. Right? There's variations on this, but this is a pretty typical question. Yes, I know it has inverse sine, and that may or may not be positive, but don't worry about that. You also are looking at how you would create this picture, right? So you draw a right angle triangle, and you imagine that this fella is the angle theta. I guess I should say it this way, that theta is this angle. Then if I take the sine of both sides, isn't the sine of theta going to be 3/4? Now, these questions are not going to be dealing with the first, second, third, fourth quadrant stuff. Not right now, right? So we got 3/4. Call this angle theta, and then create your opposite, your adjacent, and your hypotenuse. And look at that guy, and you can see that the sine from SOHCAHTOA is made up of an opposite over hypotenuse, which means that this guy is 3 and this guy is 4. What do I need to do to find the third and final side of this right angle triangle? How will I get it?
Pythagoras theorem.
I agree with you. So we'll call it 4 squared is equal to 3 squared plus the adjacent squared, right? And that's going to be 16, that's going to be 9 plus the adjacent squared. Subtract 9 from both sides. And then you take the square root. Now, when you take the square root of two sides, typically you would say plus or minus. But in the context of these questions, aren't these representing real lengths? So negative numbers don't make sense, right? So that's why it's only the positive guy. Which means that you can now get the exact value of this. And that's a key here. They want the exact value. You can't just plug that into your calculator and tell me the answer, nothing 0.1234. That'll get you zilch, no points, because that's not what you're going to do. That's a like 10-second button pressing thing. Exact value, you have to do that this way. Now, the cosine of the inverse thing becomes the cosine of theta, because I made theta equal that guy. So this is that. But how do I get a cosine? Well, according to SOHCAHTOA, it's that guy, which makes it root 7 over 4. Are we comfortable about how you would solve that type of question, right? So it's very procedural. You do them pretty much the same way. Now, suppose I tell you, right, that this angle here, right? Suppose I tell you something like theta is in the second quadrant. Could be. What's the cosine of an angle in the second quadrant, positive or negative?
Negative.
So if that was the case, you see that the only difference would be that. Now, if this was a test exam question, right, one in the final, and you only got root 7 over 4, but you didn't get the negative, the software is going to give you 0 points. But that's not what you deserve. You show me this working here, and I don't know how much the question, let's say it's worth 10 points. And you're going to get 8 out of 10 because you've done everything correct except the sign was off. Or maybe you did 4 squared is 8, or 3 squared is 6. You know the kind of silly mistakes we all make when we're stressed and rushing. Right? You did it right, but you did some silly calculation that you know would be wrong in a usual day, but you know, you just screwed up. Show me the working. I will look at it. I can fix, you know, I can fix, well, not so much fix it, but I can fix the points. I can give you what you really do deserve for that. The software is not good. It typically is 0 or full marks, right? You don't get a lot of opportunities for half a question. The only time you can get half the points if there's an A and a B, and you get A right but B wrong, right? You'll get half the points then. But if it's just one question and it's wrong, you don't get anything, and that's not realistic because you deserve more than that. Any more questions? I'm going to pick another one.
Can we know how long the final is or how many questions the final is?
Um,
I know
Can
that's
you know,
kinda
as soon
random.
as I have finished writing it, because there's 3 versions, it takes a long, long time to do it. I will definitely tell you. My gut feeling, and don't quote me on this because I could be wrong by 3 or 4 questions, because the way I'm building it is 1 question for each, 2 questions from each, 3 questions from each. So I don't kind of know where I'm going to finish yet. Would be 15 questions.
15?
Yes,
Oh,
1
I thought
5.
it would be like 30 or something. I was gonna be like,
Well, you know, yeah, I mean, I'm trying to do questions that have bits to them, so you have to do an A and a B to get it, or an A, B, and a C, or questions that take a lot of steps to them.
because I thought you're gonna be like 1 question for each section.
I know how many sections, well, I know how many chapters there are. How many sections are there? A lot more than that.
Like 6 sections technically per chapter.
Okay, so if there were, the last 2 are short, right? They're only 5 in total for those 2. So that would be 23 questions if I did that.
Wow. Oh, I thought it was 24. Wait.
I won't argue over 1, but you're not necessarily going to get questions on each section anyway. So, last question. Here goes. Solve. Okay. Now, there is no restrictions on this question. So in other words, you're going to have to do all the answers. You know how they do that? It's full of 2 pi k's and stuff, remember? Okay, here goes. What should I do to both sides to get closer to solving this question?
-3.
Okay, as long as you do the same to both sides. And there's a reason why I picked this particular question. What do I do to both sides now to find sine theta on its own?
Divide by 2.
How will I find theta?
Oh, and then find the
Inverse sine.
That's him. Do you recognize this fella?
oh
Indeed.
Right? I just chose that just to be silly, but yeah, it could be anything, right? But in this case, it's that guy. Now, when you solve equations, it's just the same as when you solve triangles. There is more than one answer, right? The only time there is one answer and only one answer is when they say, right up front, nothing else attached to it, find the inverse sine of -1/2, right? Just that. That's the only time there's one answer. So if you look at your unit circle, what you're basically looking for here is an angle whose sine is equal to -1/2. Agreed? That's what an inverse sine does. Is the sine the y coordinate or the x coordinate of a point on the unit circle?
y.
Okay, so we're looking for an angle whose y coordinate is equal to -1/2. Now, if you look at your unit circle, I know it's not very well done unit circle, aren't there 2 places, 2 angles with a -1/2 on them? Great. Isn't there 2 places, 2 angles that give you -1/2? Okay, so what are those 2 distinct angles going to be?
7 pi like over 6 and 11 pi over 6.
Yes. Sorry, what was that you said? My wife just interrupted me there.
7 pi over 6 and 11 pi over 6.
Right, the rest of you all comfortable about how you use your unit circle? Print that damn thing out. You're just going to be using them all over the place, right? So don't hang around. Print that guy out. Okay, now, if the question had been, with that thing there tagged on at the end, you see this little bit up here? Wouldn't your answer be both of these?
Yes.
If the question had this tagged on, let's change this a little bit. No, let's keep it. Would there even be a solution?
No.
No. And how about this last, well, second last one? There's one more after this I want to do.
One solution.
And it would be that guy, right?
Yes.
But what happens if they have no restrictions? Well, theta is this angle, and it's this angle, and then you do plus the period, whatever the period is, k. So the first one is 7/6 pi plus, what's the period of sine theta?
2 pi.
Pi.
So 2 pi k, and the other one's going to be 11/6 pi plus 2 pi k. And I'm sure you remember doing some questions on solving equations that were like that. Now, if that angle there had said 2 theta, right, the sine of 2 theta, because you can get ones, they're a bit harder to do, but you could get that, right? Sine of 2 theta. Isn't the period of the sine of 2 theta pi? So wouldn't you go here and say pi k, pi k? You see the difference? So it's important when you're solving an equation to be aware of any restrictions that there may or may not be, and also to be aware of the period of the function, the equation that you're trying to solve. And that is me for today. So I think the next one I see you is on Friday, and hopefully, as long as I don't have 42 emails and unexpected meetings to go to, I will have your all your stuff graded, and you'll be able to know by Friday what you're in, what your grade is like. That way, apart from your participation grade and your final, you'll know what you've got, and you should be able to guess what you need to pass the class or to get a 4.0 or whatever.
What if like you don't know specifically how many meetings you got, but you just know that you've exceeded 10 meetings?
Yeah, so when I say, yeah, we'll wait until Monday to do that. I won't be adding participation points till Monday's finished. So that'll give people who haven't turned up enough, a few more occasions to do so. And when I do send out the email, how many have you done? I don't mind if you get it wrong, as long as you get it wrong